We decided to do merge sort. It is a recursive algorithm that continually splits a list in half. For whatever reason, this list is empty or only has one argument. It is sorted already by definition. If it has more than that, we split the list recursively and then invoke merge sort on both halves to get a completely sorted list. Here you can see that we have 8 arguments in the list, 8 numbers. We begin by splitting it in half, the list. The list has 8 things, therefore we split it into 4 each. After this, we continue by selecting, in this case, the left split half and split it recursively, and then apply merge sort recursively in order to get this whole half sorted. And then we do the same with this half, the right half. First, we would, since there are 4, we would split them into 2, and then these 2 we would split them into individual numbers. From that, we start comparing the closest number to it. For example, 8 and 5, or wherever. We compare with whichever they just got split with, and then merge. So we compare 8 and 5. Since we decided to do from the smallest number to the greatest number, 5 is less than 8, therefore they get sorted 5, 8. Then we would compare 1 and 4. Since we're doing from least number to highest number, 1 is less than 4, therefore they're already sorted. Now, by applying merge, we would merge these two, we would merge these two, and the way to do that is comparing the first element in the left half with the first element of the right half, and continuing, seeing which one is greater, and beginning the list with those. Therefore, we compare 5 and 1. Between these two, 1 is less than 5, therefore we put it at the beginning of the list. Now we would compare 5 and 4. Since 4 is less than 5, we would put 4 at the beginning of the list. And then this half is already sorted, so we only have to include it here. Now that that half is sorted, we are going to continue to sort this half. First, we would do as we did with the other half. We would split it in halves, in 2, and therefore we would get 2, 6, and 7, 3. After doing this, we split them again, and then compare them to the one they were next to before getting split, therefore comparing 2 and 6. Once we compare 2 and 6, we see that 2 is smaller than 6, therefore this is how they're already sorted. After that, we compare 7 and 3. We can see that 7 is greater than 3, therefore we put 3 before 7, and now the 2 halves are sorted. Since already sorted, we would merge them together, apply merge sort and merge them together. Therefore, we compare the first argument on the left half and the first argument on the right half. 2 and 3, 2 is less than 3, therefore 2 goes first. Then we would compare 6 and 3, 3 is less than 6. Therefore, 3 would go after 2, and then we compare 6 and 7. 6 is less than 7, and then the only one left is 7, therefore we put 7 after 6. Now we have our 2 sorted halves that we need to merge together. Since it's a recursive algorithm, we would apply the same thing we did to when there were only halves composed of 2 elements. We would compare the first one of the right half and the first one of the left half, and whichever one is lesser would go at the beginning of the new merged list, and continue on until we complete the list. So first we would compare 1 and 2. 1 is less than 2, therefore 1 goes to the beginning of the list. Then we would compare 4 and 2. 2 is less than 4, therefore 2 goes after 1. Then we would compare 4 and 3. 3 is less than 4, therefore 3 goes after 2. Then we would compare 4 and 6. 4 is less than 6, therefore 4 goes after 3. Then we would compare 5 and 6. 5 is less than 6, therefore 5 goes after 4. Then we compare 8 and 6. 6 is less than 8, therefore 6 goes after 5. Then we would compare 7 and 8. 7 is less than 8, therefore 7 goes after 6. And finally, we have 8, which doesn't get compared to anyone and gets put at the end of the list. And that is our sorted list. Thank you for watching.